In this video, we will go over how to quickly image a cryogrid using a Thermo Fisher Scientific 200 kV transmission electron microscope. At this point, the cassette has been loaded into the microscope. The autoloader and column temperature and vacuum are fine and in the green. I will edit the autoloader by clicking on Edit Slot State to specify if the slot is empty or has a cartridge in it. Dark gray is empty and blue is occupied. In this cassette, slots 1 to 5 all have a cartridge in them, the others are empty. Now I am going to start the inventory. This will take a few minutes to complete. If an error or mismatch should occur, I will tell the core director or core staff and ask for help. In some cases, there might be an autoloader error or the cartridge might have been lost. Okay, so I just started the inventory. This will take a few minutes to complete. So while we wait, I will check to see which aperture is inserted. And I will make sure that the standalone camera and pre-specimen shutter are selected. Once the inventory is complete, I will open the column valves and insert the flue screen to verify that the beam is centered and that there is no specimen on the microscope stage. I can see the beam and everything looks good, so I will proceed. At this point, I will close the column valves and load the cartridge onto the microscope stage. This will take 1 to 2 minutes. Okay, so at this point the cartridge is now on the stage. Now I am going to open the column valves, insert the flue screen to see if this grid has thin ice. Right now I am moving the stage to see if this grid has any thin ice. This looks like very thick ice to me, so I will not spend any time looking at this grid. Now I am going to load a different grid. Since there is a grid on the stage, I will first unload it and put it back into the cassette. This will take about 1 minute. After which I will select a new grid and load it onto the stage. At this point, the grid has been loaded onto the stage. I will open the column valves and insert the flue screen to take a look at this grid. This grid has some thin ice. I can see the grid bars and quantifoil film. At this magnification, you should be able to see the quantifoil holes as an indicator of thin ice. If you can't see the holes, the ice may be too thick. Now I am going to move the stage to 1 grid square and collect a few low-dose images at different magnifications using SerialEM. Before I take the images, I will use the stage wobbler to find the eccentric height. Now I am checking the camera settings in This looks fine to me. Now to take a low magnification search image, I will click on the search icon under Camera and Script panel. I am making a new directory in the directory K3 data with the date and my initials. Now I will save a snapshot using the snapshot window and also using the Save Single option under File tab to save the image as MRC format. To take a higher magnification image at the whole level, I will click on View. Before I collect a high magnification image of the sample, I will need to autofocus. For this microscope, I like to set the autofocus target to -1 micron. To autofocus, just click on the icon autofocus in the yellow panel. The image should be away from the record area and appear under focused. For this microscope, I normally like to set the target defocus to -1. Now I will take a record. In this image, I can see many particles closely packed together. The particles are about 12 nanometers in diameter, which is what I would expect for this protein sample. I can also tell the ice is very thin based on looking at the FFT. In the FFT, I can see multiple fawn rings, and I don't see a water ring. From looking at the search, view, and record images, I can tell this grid square would be a good area to collect data. Typically, I would look at multiple areas of the grid to see how uniform the grid is or collect a montage of this grid.